Today's problem of the day, count zeros XOR pairs. Given an array A of size n, find the number of pairs I comma j such that ai XOR aj is equal to 0 and 1 is less than or equal to I, less than j, less than or equal to n. Okay, so the inputs are, we are given an array which is 1 3 4 1 4 and the output is 2. So index 0 3 gives XOR 0, index 2 4, this 4 and this 4 are the two pairs that is giving us 2. Okay, and for this one we are having this many numbers and the answer is 3. We can have this 1, this is one pair, this is another pair, and this 2 and this 2 is another pair. So what actually we need to look in this problem. Actually, when will the XOR value will become 0? Let's just have a, what you say, the table. So let's have A, B, A, XOR B. So if A is 1, B is 0, its XOR value is 1. A is different, B is different, its XOR value will be different. If A is 0, B is 1, again both A and B is having the values different, the XOR value will be 1. Now A is having 1, B is having 1. Both of the values A and B are equal, so that means the XOR will be 0. And if A is 0 and B is 0, which means both A and B are equal and its XOR value will be equal. So two values X and Y will have a XOR equal to 0 if and only if X is equal to Y. So if we have both X and Y the same value, then we will be getting the XOR value 0. So that's what we need to check inside. So let's see here also, like when we do the answer for this were one pair were this one and this one, and the other were this 4 and this 4, and both of them are equal. So that's what we need to do. We need to find such pairs, like the same pairs, and we need to count them, like how many pairs can be made with such numbers. Suppose here we have X, say some t number of times. Okay, X occurs, like the X and here X and Y is equal, so X is occurring t times. So what will be, suppose X is equal to 3, suppose. So we have X, X, X. How many pairs we can make from this 3? We can make this one, okay, 1. We can make this one, okay, we can make this one. This is basically t into t minus 1 by 2 number of pairs can be made. So this is what, how many number of pairs? T into t minus 1 by 2 number of pairs can be made. So if this is 3, we will be having 3 into 2 by 2, which is equal to 2. Sorry, which is equal to 3. It's true, like we got 1, we got 2, and we got 3. It's true. So we need, so our idea is we need to just count how many times each of these elements, how many times this one is occurring. It is occurring 2 times. How many times this 3 is occurring? It is only occurring 1 time. So even though if we do 1 XOR 3, 4 XOR 3, any other number other than 3 XOR 3, its value will not be 0. So this value 3 is 1. So how many times this 4 is occurring? It is occurring 2 times. So we can just track those count, and we can just find that count into count minus 1 by 2. We can just add those result. So that's one of the approach that we can do, and for that we need a hash map. Of course, we need a hash map in order to keep track of the number, okay, the number, and the value will be, it will be, hash map will be key value pairs, and the key will be the number, value will be its how many times it's occurring. So if we take the example 1 3 4 1 4. Okay, how many times this 1 is occurring? Initially this one, there is nothing inside the hash map, 1 is the first number, so it is now having occurring only one time. Okay, we are doing a linear scan in this array at first. Now 3 is not in this hash map, so it's also the first occur. Now 4 is also not inside the hash map, so it is the first time that we are seeing this 4, so its count will be 1. Now again 1, but we already have a 1 here, so we need to update this with 1 plus 1, which will be 2. Okay, now we have 4, and this 4 is already present inside the hash map, so we will be updating its value, which is 1 plus 1 is equal to 2. Now what we do means, now we populated our hash map. Now we go through the elements inside the hash map. So what is the number of times this 1 is occurring? 1 is occurring 2. We are having a result same. So result is equal to result plus whatever be the count. Let's say the count is C into C minus 1 by 2. Just repeat this process, and at the end you will be having a value of the result, and that result is our final result. So here our result is 0 initially, so at first it will be 0 plus what is the number of times 1 is occurring? 2. So 2 into what is 2 minus 1? It's 1 by 2. So we can make only one pair with two ones. So our result is updated as 1, which is equal to 1. So now our result is 1. Now how many times this? 3. So it will be 1 plus, we are only having 1, so 1 into 1 minus 1 will be 0 by 2, and any number divided by so multiplied by 0 is 0, so the result is still 1. We do not have any pairs which gives XOR value 2. Now 4, how many times this 4 is occurring? Now our result is still 1, so 1 plus, how many times 4 is occurring? 2. So 2 into what is 2 minus 1? 1 by 2, which is still 1 plus 1, which is equal to 2, and we can just blindly return this, and this will be the answer. So here our time complexity will be a big of n for linearly traversing the array first and populating the hash map, then another big of n in order to go through this hash map. Okay, big of n means the worst case, like we will be having every numbers distinct, so all the values inside the array will also be present inside the hash map. So we still need to scan through the hash map, so the time complexity will be big of n plus big of n, and we are making use of an extra space complexity big of n. So that's one of the solution that we can make. Let's quickly code that. So we need the answer to be in long, so long result equal to 0. Now I am populating the hash map for int num from ARR, so we need a hash map actually. So let's have map of integer comma integer, let's simply call it map. Actually we need to name it properly. For currency we can just say map. So map dot put of num comma map dot get or default of num comma 0 plus 1. This means if the num is already present, then we will be able to get a value from the hash map, then add 1 to it. If we didn't get if the num is not present inside the hash map, then we will give a default value of 0, then add plus 1. So that's what this statement says. So we populated. Now just go through each of the elements inside the hash map and do result plus equal to, let's get the count, which is equal to map dot get of key. So result plus is equal to count into count minus 1 by 2, and okay, return the result. Let's run. Okay, so this is big of n time complexity and big of n space complexity. Now in this problem, like we are actually need to have a space complexity of big of 1 even though the time complexity is big of n log n. So how we can improve? N log n means surely it leads us to sorting of the array. So it will be pretty straight itself, like we are just counting how many times each of the number is occurring, then just doing the same, that count into count minus 1 by 2. That's only like that we are doing. So let's try what actually 1 4 3 1 4. We will be sorting this, which will give us 1 1 3 4 4. So from this we can surely find how many times 1 is occurring, how many times 3 is occurring, how many times 4 is occurring. We can surely find that values and can do. Okay, so let's have a count which is equal to 1 initially. Okay, and let's place a pointer here. Now we check whether this value is equal to the previous value, and it is equal. Now we increment our count. Now we move our pointer here. Is this value equal to this value? No, that value is not equal. So we will be updating the result plus equal to count into count minus 1 by 2. We will be updating that and resetting the count to 1, because now we are standing at a new value. So our count is 1 now. Now we move this value here. Now is this value equal to this value? No, those values are not equal. So we again compute this value. Okay, so this will be 2 into 2 minus 1 by 2. The result was 1. Now the count is 1, so 1 plus equal to 1 into 0 by 2, so which is still equal to 0. Sorry, it is still 1. Now we move the pointer here. Now we check whether this 4 is equal to this 4. Yes, that 4 is equal to the other one. So what we get? So we increment our count 2. Now we also need to check whether we reach the final index, because like we are not updating our result after reaching this. If we do not update the result, what happens means we will not be adding this pair into our result. In this case itself, like if we didn't check whether the pointer is equal to n minus 1, we just left out of this loop, we come out of this loop, and what our result is holding, it's just 1. So no, that's not what we need. We also have another pair 4 4, so we also need to consider. So we need to check whether our I is equal to n minus 1. We need to specially check that. Yes, here in this case our I is equal to n minus 1, so we need to update our count. So count will be count was 1, so it will be 1 plus, sorry, result was 1 and our count is 2, so 2 into 2 minus 1 is 1 by 2, so we do 1 plus 1 equal to 2, so our result is 2. It's pretty the same approach itself, like we are just finding the count, but we are not making use of that extra space. That's only the difference. So let's do it once more, like we are sorting the array. Now let's initialize the count is equal to 1. Let's have the long, result is equal to 0. Let's have this also as long, no problem. Now for int I is equal to 1, I is less than n, I plus plus. Okay, if array of I is equal to array of I minus 1, we increment the count. If I is equal to n minus 1, the condition that I told, because otherwise we will miss the last 4 pair, or array of I not equal to array of I minus 1. Okay, what we have to do, we need to update our result. Result plus is equal to, it's the same formula. It's basically nc2, n into, what is nc2? N into n minus 1 by 2. So nc2 means it's the number of like different combination that we can make to make a pair from n characters. It's basically nc2 itself. It's count into count minus 1 by 2. Now we reset the count value to 1. So that's it, just return the result. In this case we are having a sorting, so this gives n log n time complexity, plus we are again going through this array, so big of n log n plus n, which we can say the total time complexity is big of n log n, and we are not making use of any hash map or any other extra space. In the previous approach we were having a time complexity of big of n by making use of an extra space, by making use of extra hash map. Here we just sort the array, which results in a time complexity of big of n log n. Then we just make use of this count variable instead of any count hash map. So our space complexity will be big of 1, and that's what the geeks4geeks expected. But the other one is also true. But if we were asked to do, like we were asked to find an approach for the space complexity to be big of 1, then this is the way to go. We can submit. Yeah, so that's this problem, count zeros XOR pairs.